So in this video, we are going to learn how to model different kinds of word problems using equations we've talked about in this class, in Algebra 2. And there's kind of a lot of writing on the board right here, so I really recommend you pause the video and get all this copied down. I'm going to talk just briefly about what each of these kind of equations is for. So please do pause it, write this all down first so you're not distracted when I'm going over it. So there are these 8 kinds of equations that we can use, that the most common ones we've talked about in this class, that we can use to model a word problem. And in red, what I have written here is an example of some sort of a word problem. I tried to make it brief so you didn't have a ton to copy down. But it's just a basic word problem that would match each kind of equation. And in green, what I'm going to do is write up a definition so you know when in a word problem each of these equations will come up. Okay? So the first one I have on the board here is constant. An equation is constant if it never changes. Okay? So you will know something is constant when it never changes. It always stays the same. So in my example for that, I say every single day, I'm going to look online and see how many states are in the United States. Every single day, the answer is going to be 50 to that. It's never going to change. That is constant. My next one over here is linear. And when something is linear, it goes up or down by the same rates. You guys are usually pretty good at picking out linear equations. When something is linear, it's increasing or decreasing at the same rate. So every year, my age goes up by 1. That's going up by 1 every single time. That is a linear equation. My next kind of equation on the board here is quadratic. And quadratic can be a couple different things, but the biggest thing I want you guys to remember, the biggest giveaway that something is quadratic is when it involves gravity. Any sort of problem with gravity is typically going to be quadratic. So if I throw a ball, or if I shoot a rocket, or something like that, because if you picture an object will go up in the air, and it'll come back down. And the force of gravity is quadratic in nature. So gravity is going to be the biggest thing. One other less common, but still worth noting thing, when they ask you to find the area of something, so the area of an object, that can be quadratic as well. Because you think about it, like your answer for that is usually like feet squared. You multiply one thing times another. So gravity is the big one, but also area can also be quadratic. In my example, I throw a ball, I look at its height, that's definitely quadratic. Next up, I have cubic here. And cubic isn't going to come up as much. It's harder to find uses for it in a word problem. It's real simple in this class. The biggest thing is going to be volume for cubic stuff. When you did volume in geometry, remember a lot of your units were in inches cubed or cubic ounces or whatever the case may be. A lot of units for volume are going to be cubic because you're multiplying 3 dimensions there. So I have the volume of a root. That's fine. Next up is exponential. And an equation is exponential if you multiply or divide by the same number. So if you are repeatedly multiplying something by 2, or multiplying something by 4, or dividing something by 7, whatever the case may be, if you multiply or divide by the same number, that's exponential. Another big use of exponential equations is our good old percent growth and decay. So if something is going up or down by a percent, we're multiplying by a decimal, that's going to be exponential as well. So in my example, I lose half of my money every day. You're dividing by 2 again and again and again. Since we divide by the same number, that's exponential. Next up is logarithmic equations, and those are a little harder to find in a word problem. The biggest thing, the only thing I really need you guys to remember, is the decibel system. It's a way of measuring how loud something is. So when you're talking about the decibel system, that is a logarithmic scale. So decibels, which is how loud something is. That system is logarithmic in nature. That means you have to multiply, like if you want to increase the level to go from 5 decibels to 6, you have to go 10 times as far in the x direction, which really just remember, decibel system right there is logarithmic. 2 more on here. Absolute value is when something is going in up and then down by a linear rate. It's like 2 linear parts together, either like that or like that. So absolute value increases, then decreases at same rates, or it could be the other way around. So it could also be decrease, then increase. So if it's going up and down at the same rate, that is going to be absolute value. One more thing for that one. Sometimes if you have a situation that has to be positive, that could also possibly be an absolute value equation. So if they're talking and they really are trying to emphasize that, hey, you can't have negative numbers, that might be absolute value as well. So in my example right here, a container is being emptied, and then it's being refilled. That's going to be absolute value. It makes that a V. Last equation is a new one that we have not addressed, and we're not really going to, but it can pop up on the EOC. A periodic equation is an equation that rises and falls in a pattern. So rises and falls in a pattern. Specifically, I kind of think about it like it's rising and falling in waves. So to picture, if something is going, you guys can still kind of see over this part, it goes up, it goes down, it goes up, it goes down, it goes up and down in a pattern like that. That is called a periodic equation, where it just keeps rising and falling in the same pattern. So if you think about sound waves, you can picture, like you've seen it, I'm sure, on a video or something like that, where the sound wave makes like a pattern like that. That is called a periodic equation. So all 8 of these equations can pop up. You kind of read the word problem, and you decide what fits best.